So just to wrap up, just a little things about different types of ones that you're going to see. Either you saw them yesterday, you're going to see them. But just so you're all on the same page, if it's called an alkane, it is a hydrocarbon that's all single bonds. So we'll just draw an example. I mean, there's a million examples, but an alkane would just be anything with carbons that are all single bonded. And again, we usually don't draw the hydrogens. It, again, doesn't mean they're not there, but that's what a typical alkane would be. And if we say an alkane, that's what we're talking about. We're going to look at alkenes, and what you're going to see is the "ene" ending indicates a double bond. So it's not telling you where it is, but if we take kind of the similar drawing as above, an alkene would differ because at least one of the carbons would have a double bond in it. You could have more than that, it would still be an alkene. It just means that there's more than that, more than one. And again, alkenes are going to be more reactive. And they're going to have a little more interesting chemistry to them. And then there's also these things called alkynes that mean a triple bond. And again, if it's going to look very similar. It's just going to have a triple bond. Now you want to keep in mind that carbon can only ever have 4 bonds total. So if you have this double bond here, that means this carbon already has 2 bonds on it. So what that means is it would only have it would have a hydrogen here, and it would have a hydrogen here. But you can never have more than 4. You always only add up to 4. So these two are what are called unsaturated, the alkenes and the alkynes, because they're not saturated with hydrogens. The alkyne, this guy already has 3 bonds, so like he, for example, would only have 1 hydrogen here. And we didn't draw them on every carbon, you're welcome to, but just to show you, like as you have double bonds or triple bonds, what that means is you lose hydrogens other places. 2 other types you just want to see, a cycloalkane. Cyclo means a ring, and an alkane means single bonds. So it would just be something where you have carbons single bonded together, but it does happen quite readily in nature. They actually form a little circle, ring, whatever you want to call it. And our last type of just things is called an aromatic. They're called aromatic because they have a good aroma. And the most famous one is called benzene. It's really big. Benzene, they knew it existed, and they knew it had a formula of C6H6. Let me just write that, C6H6. So they knew it had occurred, but they didn't understand how it could exist. And it ended up that the guy that discovered it actually had a dream, and he dreamt of one of the Chinese dragons for Chinese New Year, and in his dream the Chinese dragon for whatever reason came around and bit his own tail, and that actually gave them a clue as to what benzene looked like. So the quintessential one is it's 6 carbons in a ring. So let's draw our 6 carbons, and I'm not very good at drawing, so I apologize. And then what they found is it's like an on-off switch with singles and doubles. So like if this top one's a single, then this one over here is a double. And then the next one has to be single, and the next one's double, the next one's single, the next one's double. So that's one way that you can draw it. Over here I'll just draw it another way if you want to. It means it's the exact same thing. It's just that what's cool about benzene is you have more than one way to draw it, which makes it a more complicated molecule. And really the only difference over here is wherever there were single bonds, it would be a double. And whenever there's double bonds, there's a single. And what they actually found is that neither of these 2 pictures are really totally correct. What they found is it's kind of like a blend of them together. So a lot of times what they do when they draw benzene is they draw a 6-sided ring. And then what they do is they draw a circle in the middle, because it's like that single and double is like smeared across the middle, which is called a hybridization situation. And it has resonance, which if you take AP Chem or you take it in college, you'll hear a lot about. But this is the most classic one. And the last thing I just want you to know is that there are these things called structural isomers. And a structural isomer is that you have the exact same molecular formula, but you look different. You inherently look different. The more carbons you have, the more isomers you have. So we're going to do a very simple one. We're just going to do 5 carbons. And if you have 5 carbons, there are 3 ways to draw it. So I'm just going to show you the 3 ways to do it. All of these things would have this formula right here: C5, H12. So we're going to have 3 isomers, and that's all that's possible. You can't draw any other ones. So the first one is really simple. We're going to draw 5 carbons straight across. And if you draw 5 carbons straight across, that's the simplest way you can draw it. And if you give this guy a name, from what we did earlier, you would call him pentane. So he is your first possible isomer. He is a way of arranging 5 carbons and 12 hydrogens. And again, I didn't draw my hydrogens in, but if you drew them in and you made sure carbons all had 4, then he would make it work. Our second isomer is this guy right here. So we can have 4, and then we're going to have a methyl group. So if I can give this guy a name, this would be a 2-methyl butane. And that's our second one again. You count them up, we have 5 carbons. You draw in all your hydrogens, you have 12 hydrogens. He is exactly the same amount of elements in exactly the same ratio, but he is in a different shape, and that means he's going to act differently. And the last one you can do is this guy right here. And this guy's name is 2,2-dimethyl propane. No matter what other way you would try and draw it, if you name it appropriately or if you draw it appropriately, you are drawing one of these 3. So again, when you get 6 carbons, I think there's like 7 possibilities or something close to that, and you get much, much, much more. I think if you have 10 carbons, you have over 75 possibilities. So you get a lot more isomers very quickly the more carbons you have.